I'm Craig Little. I'm one of the sales engineers for the West Coast for SUSE.
And I'm Alan Epps. I'm one of the Boeing engineers / now architects for certain things. So.
And we're going to talk about the good, the bad, and the ugly of System D. And this was a fun title that I was throwing around with Greg, who actually didn't want to be here today. I think he could have, but he's been traveling a bunch, taking care of updates on their HPC environment. He actually titled it, and this just wasn't nearly catchy enough, Effective Containment of HPC Batch Workloads on a Shared Node. It just doesn't come off the tongue quickly. So I kept the good and the bad and the ugly of System D. But this is the piece that we're going to talk about. We're going to talk about Boeing's overall solution to helping protect those HPC workloads from rogue applications, rogue users, bad programming, a variety of things. So, welcome and introductions. We kind of already did that. You know who we are, what we're going to talk about. We're going to roll through a little bit of a background of System D. This is not really meant to be a deep dive System D type of presentation. We're really looking at a specific use case that Boeing is using to contain it.
An extensible use case.
Yeah, an extensible use case to contain things using the System D components. But we got some bad and the ugly, which is kind of what Boeing ran into, that we're going to talk through and talk about some of those use cases and how you might be able to take this in your own environment and move it forward. So, System D. Do most of you remember when this came in with version 12? How happy were you? I know you're not.
I'm not.
Still. You're holding a grudge still. But and it's okay. But it changed the way the system starts up. And there's some reasons for it. There's some good things going on with it. But it wasn't the same as the old. Took some learning, took some time to get used to it. There's some good tools. You know, the on-demand starting up and the good reporting back of things, snapshotting and restoring, mount point pieces. There was a piece that I just learned when I was preparing this. I didn't know you could set up essentially cron tab type of things using the time units in System D. And well, that's kind of cool of being able to do that. I don't know how often I would do that. But it makes it easier to do the supervise and control those pieces, the C groups. There's some good stuff making your life easier with System D. More detailed error messages, though we don't collect it in the support config. But the info is there. Using the control groups and building it up in a hierarchy-based design makes it easier to do some cool things. Also breaks some things, as we found. And then we've got these cool new tools, system CTL, journal CTL, and then the system analyze. We've got those new tools that are part of System D. How many get along with System D now? Okay, so it's not horrible. I won't say you love it.
It doesn't scale either. I have multiple requests open to get upstream fixes for scaling issues.
Okay.
I'm especially on 896 core systems and stuff like this.
The big.
The very big iron.
Yeah.
So, and they're getting fixed. It's rolling out now.
Okay.
But it's stuff like that the guys who wrote it on little 4-core or 8-core systems never run into.
But these are the big
Superdomes.
Yep.
Yeah.
Yeah, we've seen the same thing.
Yeah. But you know, some of that it's inherited engineering. You know, because that's the old SGI boxes, and so you guys are putting some of that engineering together finally. And then SUSE, you're right. Our engineers, we don't have a lot of Superdomes hanging out in Germany, unfortunately. I would love one. You know, if you got a spare one, I could make friends with all the engineers in Germany. But there is some good with System D, and we're going to step forward, if you don't have any other questions at this point or comments around System D, and let's talk about what Boeing's use case was around the HPC pieces.
So, again, I'm Alan Epps. I'm with Boeing. I'm one of the Linux engineers / architects within core engineering. Greg Sekas and his team run the HPC environment in Boeing. To give you a sense of scale, when I walked through the door a year ago, it was just south of 3,000 machines. I believe as of when I left on Saturday, they're somewhere north of 5,000 machines, and our management is looking at an ability to burst utilization over 8,000 machines.
And these aren't little
No, there's a lot of very beefy boxes. As a consequence, it's a huge environment that has thousands of users between exterior staff, contract staff, and core employees. We're over 250,000 people. Out of those, a fair amount are engineers. Out of those engineers, there's a lot of them that work on things like landing gear folding and aerodynamic stresses on engine parts and rocket nose cones and everything under the sun that you can possibly imagine goes through some sort of computer modeling before it goes through destructive testing. As a consequence, the HPC guys get pounded, and those systems...
How big is Greg's team?
5, 6?
6 people?
2 open recs.
Any HPC gurus?
Yeah.
Greg would love to hear from you.
Very serious on that. There are 2 standing open recs right now, because at this level, with this size and scale, the experience pool of folks that have worked at something like this is pretty small, and most of them are at a national lab in some country somewhere.
Hawaii is a favorite one. the telescopes there.
Yeah, as opposed to Lawrence Livermore or some of the others. But anyway, it's a huge environment, and they share it across thousands and thousands of engineers. Originally, it was a relatively easy community to track, but as they've developed more code, as there's more systems processing and more jobs in queue, they needed to start narrowing down where people could go and make it PhD resistant, I guess would be the way I'd put it.
While early on, they knew all of the people that wrote code.
Right.
They could go to those people and go, hey man, your code sucks, fix this. We're finding these issues. But with that pool of users today,
Not
only
anymore.
6 people, they can't go validate that the code is good and solid coming into the cluster. And it comes from so many different parts of the company. They're going, and with only 6 people, how do we protect this?
Right. So they have locked things down per SUSE best policy in practice, and then went multiple steps further.
Right.
So,
And so they initially built this under SLAS 11. As of, when was it, a month ago, there was, the bulk of it had been moved over to SLAS 12.
yeah, there's only about 1,000 machines still in the 11 space.
Right.
It's a slow process.
Well, it's a lot of nodes in multiple locations.
Right. So using the C group process is eventually where it gets to. But they start by isolating CPU memory, device access, and process level access. Again, across multiple cores, multiple buses, multiple boxes, because those of you who aren't familiar with the HPC space, there's a control node and worker nodes underneath it. Everything is submitted to a batch distributor on the control node, then shoves it down to the various worker nodes underneath. So
But there's also some of those jobs are interactive.
they are.
And
A
so
lot
now
more
you
of them.
Now you have logins happening down at those batch nodes.
Right. And more of that stuff is interactive, because as the engineers and as the scientists see processes unfold, they go, oh, wait a minute, what if I tweak this parameter? So in real time, it's rerunning calculations, hence the
Or a
interactive.
fair amount of, oh crap, I did that wrong.
No comment. So again, they started locking things down tighter and tighter so that certain groups only had access to certain things. That's driven not just by a resource configuration, but also by government restrictions, because Boeing does a huge amount of commercial stuff, but we also build things for various government structures, and those are constrained, as anybody can imagine, pretty heavily in certain cases. So the C group structure allows them to very tightly control, monitor, and manage who can access what resource at what time, largely so that we can move the non-commercial workloads off of a system and purge it completely before anything else can be loaded in or anyone else can access
Well,
it.
and the other side of it is Boeing over time has moved from I'm just dropping a single app onto that node
Yes.
to multi-tenancy. They're eking every last little CPU cycle out of that.
Yeah, I think across the entire environment of the HPC, they run at 99.8 to 0.9 utilization, 24 hours a day, 365 days a year.
That's for that.
Cook a lot of hot dogs. This top one is the most important thing. I don't know how many of you worked in ivory tower worlds with lots of PhDs. They're brilliant, but they have this massive tunnel vision where they see their world and they don't necessarily get everything around it. And so they code and develop and build and design to meet their requirements without actually thinking about how that can have ramifications for anyone else.
And that's on the makes mistakes.
Right, right. And when it was single user, single platform, that wasn't such a big deal. But if I'm running a rocket exhaust model that suddenly is gobbling everything on a 128 core box, everybody using those other 128 cores gets a little mad at me when their jobs stop. The sneaky thing, I'm not privy to any actual events, but the potentiality exists, so we have to be careful about it.
Well, especially with that multi-tenancy of protected,
Right.
controlled types of process.
And that's only become a bigger issue over time. And again, this all used to be batch-based. You throw your stuff in the queue, it lives in the queue, and those queues could be visible at one point as well. That also has been addressed as we move through this process.
And it's easier to control it when it's coming through a batch, because the batch scheduler then kind of gets to own that job.
And it's predictable.
But now with those interactive login jobs,
It's not so predictable.
there's a little more thing going on. So 3-level strategy.
So we have this PBS piece that gets passed the minute a user submits a job, it gets assigned this PBS ID. That ID then goes with every login, with every access, with every process, with every in and out to a disk or memory, you name it, that PBS piece goes with it. And that worked great until, again, hello PhDs, they're in the box, they're doing something interactive. Oh, wait a minute, this doesn't look right. Let me go over to this process and see if it's the same. And the minute they did that, they were outside their constraint world. Wasn't necessarily a problem, except when they then started up another job that didn't have that buried PBS ID, they're gobbling resources because that ID is no longer constrained. So we stuffed that job ID into PAM and then said, okay, you pass this everywhere for any access on any host at any time within this environment. All of a sudden then, the PhDs quit breaking things as often. They still do, but just not as often. And I don't mean to pick on PhDs, it's just an inside joke. So now, everything has this ID tagged to it. It follows it everywhere for each job. Even if you start up another job in another node space, again, in this interactive world, it will continue to track that. And part of the reason, welcome to the horrible bean counter world, is we charge back to the various projects based on CPU cycle. We don't, I believe, hit them on memory, but we do hit them on disk. So if they're spawning stuff we don't track, then the bean counters come and yell at us. So again,
He gets hit with a big bill, he can't run any more machines, HPE is sad.
yeah, it's not a good thing.
It's this downhill thing.
Right.
But we did solve SSH.
We did, and it worked great.
So we have 2 of the 3 now.
So again, they start limiting based on these config rules, where they go, how they go, what they're allowed to access. This was that piece that I was saying, this create and destroy rules. This is that part that purges and cleans before the next job runs in. I pointed specifically at the government jobs, but it actually matters for any job. Some of this stuff is written in languages that don't exactly clean up after themselves well. So it is occasionally a good idea to force clean a lot of things. And we actually force clean disks as well for some of this stuff. So, and again, I don't want to read these slides. We're all adults. Everybody can read them. So I'm kind of speaking around them.
But this was fun.
This is Greg.
Because when you're running at this level of use, with this kind of jobs and the number of CPU cycles that these guys are flowing, yeah, they find some issues. And the kind of things, this memory leak. And this was funny, because they took it up through HPE support and SUSE support. Did you see this come through?
Yeah.
See? You were involved here.
Yeah.
And do you remember what the fix was?
I didn't know personally own the case, but one of the
So,
other guys on the team, yeah.
It was a comma.
I did not know that.
It literally was a comma in the code, and the comma and a delete. They had to delete 2 characters or something. It was that little bit, and then the code worked fine. But there was a memory leak. Greg found it. It caused him a lot of grief for a while. And that was part of why they started doing some of those cleans.
Yeah.
Is it just,
50K plus each time, and how often was it reloading?
oh, often. Because as jobs would spawn, and especially the interactive, when they were coming in and out, and multiple SSH sessions.
Depending on the node, I mean, some of these things are run times measured in weeks. I mean, if you're modeling a rocket exhaust for pressures and acoustic vibration and everything else, those are huge. But some of them are really, really small. What's the break strength of a certain strut end at a certain angle? I mean, those will finish in an hour or 2. So predicting how often you hit this, you can do a delta across the whole thing, but for an individual job, it was tough.
But it still was causing problems.
But it was definitely causing problems. And it would, lucky for everybody, cascade across the nodes. And it was not predictive as far as time or where it would happen next, which was part of the fun of chasing it down.
But we got it solved. We teamed up with HPE and SUSE Engineering and got it taken care of.
Absolutely.
And that was good.
And I am not going to read this to y'all.
Point that line out? Yeah.
Not even close. But this is modifications we did in-house working with SUSE to make sure that our structure, our control structure, would then get put into properly this libc group.
So at this point, this is all working in SLUS 11. And working, got it tuned up, took them some time to get here. But it's working very, very well. Guess what?
So again,
12 comes along soon, but
right. So again, everything comes tied to this ID, and this ID actually feeds into the SSH. That's not exactly worded properly. And this thing controls all access to every resource, including getting off the box and going anywhere else. So it works, and it works flawlessly in 11. We have no problems. It's as bulletproof as you can make it.
so they had stayed away from 12 because they were happy. They were happy, everything's working, we got it all contained, and then SLUS 12 SP2 comes along. HP comes out with some new hardware that required SP2 and the kernel in it to work, and guess what? They're going, damn it, now we gotta go to 12. So they start to put this into 12, and it broke spectacularly. System D changes all the rules, and
All the tool sets that this is built off are deprecated and no longer initially installed.
lots of funness here.
Not pleasant.
But I got to know Greg really well through this process. Got a good relationship with Greg and his team now, and that's good. But we were working through some things, and the libc group 1 is now obsolete. Simple solution. Back to that one fix was a comma and killing a couple of characters. The new solution under System D is outlined right here.
So basically they take all of the assets and control them with one space.
So, because when I was talking about System D to begin with, what we were talking about there is there's this hierarchical structure of all of these components. System D carves them all up, breaks them all down, and allows you to control them and keep track of what's going on those individual levels, which is good most of the time until I'm trying to build containment. And now that I'm trying to build containment, this gets a little uglier. But this join command literally pulled it all together. It was one of those, it was a lot of heads beating on walls and tables and tried to get it figured out, and Greg and team goes, just join command. Done. And they're now have been running it for a year and a half.
With 0 issues.
With 0 issues. It's a really very cool solution to being able to keep that control and containment. And it works really very well. Now, the question that I'm going to have past 15 is going to be, how long do we keep libc group around? And some of that code.
And they're already looking at, okay, how can we move this somewhere else? Is there our own internal code that we can write that then can take the individual devices, do the same thing without having them run off that libc group? Because that's just one of those things.
The bulk of the engineering's done. They understand the solution. It'll be easy enough to move this forward into the 15 range. Is there questions on the use case and how Boeing has solved it at this point?
This happened only on HP.
Say that again?
Did this happen only on HP or
No, it is not hardware dependent.
Right. This is really Linux. This is built into core Linux and use of the systemd resources and libgroup.
Now, that being said,
C groups.
we haven't tested on Power and we haven't tested on the Z series. So
Right.
if you're the IBM guys running really big iron, we haven't tested yet, we don't know. Mainly because corporate won't give us that particular toy as much as we ask.
Yeah.
So,
As fun as it would be.
right.
But at this point, everything that we've talked about so far is just core SUSE Linux. We really haven't branched out
At all.
into any weird modules or anything of that nature. And so it should be pretty clean across potentially those other platforms.
Yeah.
But
Should
there's
be.
nuances there. Probably work on ARM.
Please don't give Greg ideas. Please.
Good. A Raspberry Pi HPC cluster?
I'm leaving now.
Just a
So-
quick question. What was the problem with SLS 5? By 15, you said libc?
No, they haven't tested with 15 yet. They're
Okay.
running 12.
All right. You don't
on the-
expect a problem.
I don't expect a problem,
Okay.
but just keep in mind the libc group code has been depreciated.
So to speak to that a little further, to say that this team is conservative to the extreme makes it very, 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 very small statement. This has visibility all the way up to the sea level all the time. Last year, without disclosing too much, last year management came to us and said, we need for you to move this into the cloud because we need the ability to burst to thousands of machines in a week. So Greg went and ran some numbers and said, so for this many CPU cycles and this much memory on this many spinning platters, it's going to cost you this humongous amount to move this to the cloud. It'll cost you less than half of that to move it to our internal cloud, or you can spend a quarter of that and just give me the machines I asked for to start with. But again, it goes to that level because we have burst needs occasionally that truly boggle the mind.
Well,
So-
like you said, that HPC cluster is currently running at 99% utilization. There's no free cycles on it.
Yeah, none.
It just gets used.
He's got a backlog that continues to grow. I mean, it's ridiculous how hard it gets
Which
pushed.
is the reason that it's taken this long to get to SLS 12.
Yeah.
And that there's still a handful of SLS 11 boxes. So one of the things that I wanted to branch out, because I loved this solution when I was working with Greg on it and with Ellen, what it does around containing apps, containing SSH sessions, things of that nature, I'm going, there's some cool things here that have uses outside of HPC. So that's one of the pieces to kind of keep in mind. While the HPC use case makes a tremendous amount of sense, there's, all of those reasons that we've talked about that cause concern. And at the end of the day, this small team, really, their whole goal is to keep that stack running at 99% utilization.
And to make another point clear, it's not just constraining what the end users do or what their processes do, it's also constraining the memory footprint they have, the CPU footprint they have, and the disk footprint you have. So if you think about it in terms of everybody's favorite leaky language, Java, it is gently notorious for spilling out of its gateways. This locks that down very tightly. As far as I know, they've never had anybody transgress outside their boundaries with this. It's really slick.
Times when they've lost an application and it's overrun most of the machine, they've got the Core 0 CPUs still protected.
Yeah.
Where they've always been able to get into the box and go clean house on it when needed. You know, to where, again, the PhDs will pick on the smart guys. When they write that code that overruns the whole box because they weren't paying attention, you can't do that in this mode. To where they still are always protecting those core kernel pieces to where they can always get in and fix things as necessary.
And with the new C group stuff, they can't even go to the next core. It literally defines, here's your access, here's your memory footprint, this is what's going to be scrubbed when you're done. You can write stupid code all day long. It can't get out of the box to go attack the next piece over.
Right. So HPC is a great use case. Application servers. Because Java, like you were just talking about, Java server. I would love to be able to easily wrap containment around Java apps. There you go. Work within this space and die when you can't work within that space, but you're not going to take out a machine. I see this both from application server and potentially application admins. Application admins, you can let them go do the things they need to do to manage their app without letting them into the rest of the box. There's some cool concepts there on being able to do those two things. Jump boxes. This was the other one when we were working through the SSH pieces, and I'm going, you know, jump boxes, because if you're working in a highly secure, multi-layered security type of environment, jump boxes are a way of life. They're a pain in the butt, because you have to log in here to then go be able to log in here, and you got all the firewall pieces and all those things going on. But if I have the controls to contain those user sessions, now I know they can't jump and do privilege escalations and all types of those fun sorts of things.
Even if they do privilege escalation, because as you can imagine in this environment, occasionally there are things you need to do with elevated privilege. Because the way the systems are built, you cannot get into the system and trigger any sort of process without having that initial ID on it. So even if you become root, that ID is going to wander with you. So I'm root on this box and I wander over here, that ID still goes with you, and every process you start, every job you run, every file you look at still has that ID attached to it. So
Still has containment.
it's pretty cool.
Lab and education type of environments. I can see this being huge in academia. Where here, let's put all the constraints around. You can go do what you need to do, but you're not going to tear up the machines or take absolute control of the machines.
I mean, somebody might be smart enough to do it, but it isn't me.
And then multi-tenancy, you know, which was one of the design components initially, was that concept of I got to have multiple jobs running on these boxes. Because I got big 128 core type of boxes, I got enough room to run multiple jobs, but I need them contained. But you could do this if you were an application provider, potentially. You could then put the security around multi-tenancy and be renting out the machine and have it truly carved up.
Yeah.
So there's some fun things. Questions at this point?
So your join that you did is overarching, it's everything?
Yes.
So how well does it work if you add others? Can you flexibly add others?
You can. Again, it's based on that profile that attaches to that initial ID process. So when we define that, or when they define that profile for the jobs,
Right.
that builds your constraint. So if we modify that on the fly, the next time you log in, and that is one of the things they get whined about is, what, I have to log back out and log back in? Yeah, I'm sorry. You're changing your environment. But yeah, all they have to do is log out, log back in, and the new resource is automatically there.
So you could easily have different ID for different class of users.
Absolutely, absolutely. And to be honest, though I don't think Greg knows, or maybe hasn't officially said this, if you modify that ID and constraints on boxes A, B, and C, and you move to D, E, and F, that new login has new constraints. We don't generally allow that because then they have jobs running in 2 places when they're only supposed to have jobs running in 1. But I've tested that and that does work currently, so.
It's cool stuff. Like I said, it was one of those solutions that at the end of the day ends up being a fairly elegant solution to achieve a pretty critical need in this environment.
Yeah.
So if any of you guys want to do this in your own space, let me get back to, there is some great documentation on the libc group pieces. This tuning doc is actually really very good. The open source, the open SUSE Elite docs were better than the core SUSE docs. So notice that's why I have the Elite docs up here. They did a much better job of describing some of those pieces. And then the system D pieces there, and then the tuning C groups on that one. So please take a look at those components. Catch either one of us on the floor or around today. Love to chat further on those. It's a fun, elegant solution. Any other questions?
Yeah.
Yes.
Those users are contained in a C group, a resource group. How do you manage all those resources?
This environment has its own LDAP configuration that's isolated from the rest of corporate. Again, due to the nature of this work, we have built an infrastructure around it that is isolated from other places. Luckily, in general, this user community doesn't have a huge amount of churn in it. So it's relatively straightforward to constrain the groups. And when there's a new project that's starting up, say we're going to test a new landing gear configuration, that's a new official project. Boeing is kind of glacial. Somebody pulls the trigger on let's start this, and it can be quite some time before somebody's ready to work on it. So there's some lead time to get some of that configuration done up front. But yeah, we have a standalone LDAP just for this environment.
Those rules are directly linked at the moment they need it?
Yes. Yeah, so there's a table space that anytime a user logs in via that LDAP process, it immediately goes and looks at their constraints, where they're allowed to go, how big they're allowed to be. Because of course there are some people that are allowed to gobble huge amounts, and then there's some that are only allowed small. So.
Right. The ones with the big budget.
Yes, very big budgets.
Yeah, that's an excellent question. Yes.
I know it's not generally part of C groups and this stuff, but have you ever had to deal with fairness or sharing, like network resources or remote file systems?
There is no fairness. No, I make that statement in all sincerity. If you've been assigned CPU, disk, and memory on this box, you own it. And the reason we constrain it is so you don't step on the guy next to you. But there's no playing fair. There are people who literally can preempt the next 3,000 jobs and take 52 machines. And the people that got bumped just have to wait. It's not a play nice universe, it's a prioritized universe. So.
How do you track this allocation?
How do we track?
This allocation, like.
So the config is really around that LDAP source,
Right.
where the constraints are built in based on the project group and based on the requirements that were delivered on those projects.
So certain of those IDs that are identified in LDAP are allowed to log into certain boxes. And then inside those boxes, they're allowed so much CPU, so much memory, so much disk access.
And again, that's part of the not playing fair. Your project gets this other project gets this,
Right.
based on the business priorities. Yes.
What are you using to monitor all this?
I don't know that I can speak to that, but a lot of it's in-house.
So there is a fair amount of in-house code. They are also using Brightworks as the HPC overall management, and that's the one that's doing the job scheduling pieces.
So you baked your own internal.
A lot of the stuff.
I mean,
The
like,
management of the LDAP and all that is
yeah.
all internal.
I mean, like a lot of companies, we don't buy anything off the shelf and leave it alone. It is always Boeingized. We always tweak everything. So yeah, it started out as some different commercial, some open source, and has been gently massaged. So, can anybody see where this might be useful in, just as a show of hands, in their environment?
Oh, yeah.
cool.
Okay.
Very
So
cool.
I'm going to go a little deeper. I love that. What kind of environment? Still in HPC, or are you guys looking at other sorts of places as well? Other
We
types
do
of use cases?
HPC specific stuff, but definitely from application corralling.
Mm-hmm.
We've got people with Java machines. They just love to vomit and just take over the system.
Unfortunately.
This would be a perfect use case. there.
Yes.
Yeah.
No, this would definitely be good stuff. Anybody else?
Some of our internal debug analysis systems where we have L1, L2, well, L2 joining us on an L3 system could use this.
And to be honest, to your debugging, one of the places that we're looking at using it in a separate team is everybody likes containers and everybody likes VMs and da-da-da-da-da, but every once in a while, I want to know what's going to break my big physical box. And this lets us kick the snot out of certain things without beating up anything else. So, again, in that deliberately not nice, don't play well with others kind of way. So.
Yes.
You kind of mentioned that already, and you might have started out with that a little bit late. But did you ever look at actually containers, like plain LXC containers?
So, containers and HPC most of the time don't play well together because of the nature of the batch jobs. There are symphonies and there is a container structure specific for HPC, and the name's escaping me at the moment. But like regular Docker containers or whatnot don't do well in the HPC space.
I don't know, that's why I mentioned specifically LXC, because I mean they use all this infrastructure that you use, the control groups, and it is basically to contain resources, right?
Right.
But you didn't look at that.
It didn't exist. Yeah, it didn't exist when we built this. So
this has been running in the Boeing space for quite some time, and it really reared its ugly head with the bringing in SLUS 12 and System D.
now I will ask when we're done, I'd like to talk to you, because if there is an additional tool, sooner or later Greg's going to come down the hallway and talk to me about it. So if I can get ahead of him, that would be cool. So please.
Yes. Any other questions?
So this works well with, I assume you're using like MPE Run or something, some of the HPC tools to distribute it, and
Well,
you've got constraints on top of it.
Right.
Yeah.
So
I'm
Brightworks
assuming the
works.
Brightworks does that.
It
Yeah.
works well with it.
Yeah.
Yeah, because that's been part of the overall solution there for quite some time as well.
Any other questions, comments?
We rolled through that one quick.
Yeah,
This
well,
was good.
I don't do stand-up comedy, so
Tap dancing?
as fat as I am, no. No.
Well, guys, thank you for your time today and your comments and questions.
Absolutely.
I very much appreciate it, and thank you.
Thank you, guys.